Okay, so now we're going to start coding the bubble sort, and this is a program that we've actually done before. This is parallel arrays with dwarfs and the number of pounds of coal that each dwarf has mined for the day. So I'll just run this really quickly. Okay, so basically what this program does as is it'll loop through the arrays in parallel, print the name of the worker, the dwarf, and then the number of pounds of coal that he mined for the day. Notice that the coal is not in order. What we're going to do is sort the coal array so that the pounds of coal are in order top to bottom. So Dopey will be up at the top with the 4, and then I guess Grumpy and Doc will be at the bottom with the 11. So let's go ahead and look at this. Now, when we were explaining the bubble sort in the previous video, we said, oh, don't worry about the dwarves for now. But in this program, we are going to have to worry about them. But first things first, let's talk about the bubble sort. So looking at the mechanism for the bubble sort, we said that basically we're going to write a loop that will look at the current element, compare it to the one next to him or the one after him, and if they're out of order, we'll switch them. And that loop runs through the entire array, and we have to be careful not to go the entire length of the array, but really the length of the array minus 1, because at the bottom here, at the last element, there is no next element to compare to. So you have to be real careful about that. So that loop is always going x minus 1 times, where x is the number of elements in the array. Okay, and then we also said that one time through or one pass through the array is not going to cut it, so we have to do a nested loop which also runs x minus 1 times, where x is the number of elements in the array. Only then will we be guaranteed a complete sort. Okay, so let's set up our nested loops, and you know these loops have got to run 6 times, right? Because the number of elements in the array is 7. 7 minus 1 is 6. Okay, I could hard code a 6 in my loops, that's fine, but why don't we just isolate the length of the array or the number of items in the array and then use that instead of hard coding a 6, because I know there are always 7 dwarfs and probably always will be 7 dwarfs, but what if we did have a new one come to work at the mine and then we had 8 dwarfs? Then we would have to pick through the code and change all the 6s to 7. So it really, let's just isolate the number of dwarfs. So we'll say, how about dwarf count equals, and then we'll use our array dot get item count method. And you know, I'll just put the dwarves array in here. Okay, however, I could have just as easily put the pounds of coal array in here as well, right? Because both of these are parallel arrays. They both have the same number of items. So it really doesn't matter which one we use. Okay, so now let's set up our nested loops, each of which will go dwarf count minus 1 times, because dwarf count is the length of both of these arrays, basically. So I'll use x for the outer loop counter, so we'll say for x equals 1, 2, dwarf count minus 1. Okay, and then I think I'll end this loop sandwich before I think about the other one. Okay, so that's the outer loop, and now we have to go the inner loop, and we'll use y. I guess the most important thing is don't use the same loop counter variable. You can use whatever you want. I'll typically use x and y, and you'll see that a lot. But or you may see I and j in a lot of textbooks, but just don't use the same one in both cases. Okay, so this is also going dwarf count minus 1 times, and don't forget, this is a sandwich inside of a sandwich. You have to close your sandwich. Okay. All right. So really, all of the code to accomplish what we need to accomplish is going to go inside of your inner loop. All right, and what's happening here? Well, we're going to look at the current item at hand and compare it to the one next to him. If they're out of order, meaning if this guy is greater than the one next to him, we're going to switch them or swap those values. Okay, so we have a little maneuvering to do here. So we'll say if pounds of coal y, the inner loop index, Okay, you're not going to use the x at all inside of this inner sandwich. Okay, so if pounds of coal y is greater than, how do we access the guy next to him or the guy right below him in the array? Y, pounds of coal y plus 1. That'll point you to the next element in the array. Okay. Then I'm going to end my if because I don't want to forget that later. Okay. If he is greater, then we're going to swap them or change those values around. Now, how are we going to do this? Well, basically, I need to get the 5 where the 7 is and the 7 where the 5 is this first time through the loop. We'll just focus on these first two elements. How can I do that? Well, you know, if I assign element 1 a 5, now I've lost the 7. Okay? The reverse of that, if I were to assign the second element a 7 first, then I've lost the 5. So what we need to do is really create like a temporary variable or some sort of like temporary holding location. Okay, so we'll create like a temporary variable. We'll assign the current element, which will be pounds of coal y, in this case the 7. We'll assign that value to the temporary variable. So now he's safe and preserved. And then what I can do is move the 5 into here, and then take our 7 and copy it into that location, the y plus 1 location. So it's like this, almost like a rotating variables type of mechanism here, almost kind of like the way volleyball players will rotate on a court. Okay? So how do we do this with code? Well, it's really just 3 variable assignment statements. First, we're going to create that temporary variable and put the pounds of coal y value in it. In this case, the 7, looking at those first two elements. So pounds of coal y. All right? And then we want to move this guy, this is the pounds of coal y plus 1 location, into this guy, which is the pounds of coal y location. So we'll write an assignment for that. So we'll say the pounds of coal y location takes on the value of the pounds of coal y plus 1 location. Whoops, forgot my 1. Okay, and then finally we want to put the temporary value, the 7 in this case, into the y plus 1 location. So that we just completely rotated them around with the help of the temporary variables. So we'll say pounds of coal y plus 1 is equal to the temp location. Okay? Now, let's go ahead and run this. We're not done yet. Okay. Let me just bring this to your attention. These are parallel arrays. In the top spot we have Happy, and he mined 10 pounds of coal. And then Sneezy mined 7 pounds of coal, and so on. All right. So let's run this program. All right. Now look, the coal is sorted. Okay. However, what did we say? Happy mined 10 pounds of coal, and now we have him at 4. Sneezy mined 7 pounds of coal, now we have him at 5. This is a problem. Our data is all out of whack because what we did is we sorted the coal, but not the dwarfs. These are parallel arrays, and they have related information. So what you need to do is, you know, when you're working with parallel arrays, you need to be very careful. If you're sorting one of those arrays, you have to swap values in the related array, which we did not do here. So we're not done yet. We do have to, okay, so here we swap the coal. But we also have to swap the dwarf values. Okay, So again, we'll create a temporary variable, and it's really all the same, except we're referencing the dwarves array. Okay, so put the y plus 1 value into the y value. And then finally move the temp value that we saved into the y plus 1. Okay, that should do it. Okay, so here we go, and the coal is sorted, and Happy still has his 10 pounds, Sneezy still has his 7 pounds, and so on down the line. Okay, so that's a bubble sort. Again, you need to be careful when you're working with parallel arrays. Don't sort one of them and then leave the other one alone. If you're swapping in one array, you've got to be swapping in all of the arrays.